Welcome, everyone. Today, we are diving into a crucial aspect of research methodology, the seminar presentation. You have spent months, maybe even years, conducting your research in the lab or the field, but science does not end at the laboratory door. It only truly matters when you share it with the world. In this video, we will explore how to effectively communicate your complex findings to a live audience, manage your time mathematically, and design presentations that captivate rather than confuse. Let us get started. To understand what makes a great presentation, imagine you have just watched the most amazing movie. When you tell your friends about it, you would never just read the script to them word for word. They would get bored instantly. Instead, you highlight the main characters, the biggest plot twists, and the exciting conclusion to keep them engaged. A seminar presentation in research works exactly the same way. It is your chance to step away from the dense, heavy text of a thesis and tell the exciting story of your hard work. By focusing on the highlights, you make complex zoological research accessible and interesting. Now that we have the right mindset, let us look at the formal definition. In research methodology, a seminar presentation is a formal academic event where a researcher communicates their findings to an audience. This usually happens through an oral presentation with digital slides or a visual poster presentation. Unlike a written report, which is static and one-directional, a seminar is highly interactive. You are required to distill months of complex data into a concise format that fits a strict time limit. Furthermore, it always includes a dedicated session for questions and answers, allowing the academic community to critically evaluate your work. You might be wondering, why do we even need these live events if the research is already written down in a detailed report? The primary reason is that science thrives on immediate collaboration and peer feedback. Written papers alone simply cannot provide this quickly. When you present your work live, you open the floor to questions that might point out flaws in your methodology or suggest brilliant new directions for your zoology experiments. In the real world, conferences are the primary networking hubs where researchers find collaborators. Without them, research would happen in isolated bubbles, drastically slowing down scientific advancement. Understanding the importance of seminars brings us to the most critical technical skill: managing your time. Going over your time limit is considered highly unprofessional. To prevent this, researchers use a basic time allocation model. The formula is T equals T sub I plus T sub B plus T sub C plus T sub Q. Here, T is the absolute maximum time allowed for your session. The other variables represent the structural components. T sub I is your introduction time, T sub B is for your methodology and results, T sub C is your summary time, and T sub Q is the mandatory question time. If your methodology takes too long, you must decrease your introduction or summary to keep the total time constant. Now that we know how to allocate our time, we must address another crucial metric: the number of slides. A very common mistake among new researchers is creating way too many slides for their allotted time. When you have too many slides, you are forced to speak incredibly quickly, which completely confuses the audience and ruins the story of your research. It overloads the presentation with unnecessary visual information. To avoid this trap, we must calculate the optimal number of slides before we even open our presentation software. This calculation is based strictly on your actual speaking time. This brings us to the formula for determining exactly how many slides you should prepare. The equation is S equals T sub S divided by T sub P. In this rate equation, S stands for the maximum number of visual slides you should include in your deck. The variable T sub S is your total speaking time in minutes, which is your total session time minus the question time. The denominator, T sub P, represents the average time spent talking about a single slide, generally recommended to be between 1 and 2 minutes. Notice that if you decrease the time spent per slide, the total number of slides will increase, which often leads to a rushed presentation. Let us see this formula in action with a concrete example. Imagine a student is invited to give a seminar with a strict total time limit of 15 minutes. They must reserve 3 minutes for questions, and they plan to spend an average of 1.5 minutes explaining each slide. First, we find the actual speaking time by subtracting the 3 minutes of question time from the 15 minutes of total time, giving us 12 minutes of speaking time available. Next, we take those 12 minutes and divide by the 1.5 minutes allocated per slide. The result is exactly 8 slides. This means the student should prepare exactly 8 highly focused slides to deliver a calm, professional presentation. Having calculated our slide count, let us look at how this entire 15-minute session is structured visually. On screen, you can see a timeline and a pie chart, breaking down the time allocation model we discussed earlier. The total 15 minutes is divided into distinct phases. We start with a 2-minute introduction in blue, followed by the core methodology and results taking up the largest chunk, 8 minutes, shown in green. Then, a brief 2-minute conclusion in orange wraps up the speaking portion. Finally, the critical 3-minute question and answer session is shown in red. Above the timeline, you can see the 8 optimal slides we just calculated, perfectly balanced to fit within the 12 minutes of actual speaking time. While oral presentations are common, seminars also frequently feature visual poster presentations. When you are designing a large poster for a seminar gallery, the rules of engagement change slightly, but mathematical planning remains just as important. A good poster must have a strict balance of content to avoid overwhelming the reader. If you add too much text, you ruin the visual appeal, and people will simply walk past your work. To maintain professional design standards, a specific percentage of the poster's physical space must be dedicated strictly to graphics, charts, and images. To ensure this visual balance is mathematically consistent, we use a simple area equation. The formula is A sub g equals P sub g times A sub t. In this equation, A sub g represents the physical area required for graphics. The symbol P sub g is the percentage of the poster dedicated to graphics, which we must write as a decimal for our calculations. Finally, A sub t is the total printable area of the poster board. By using this formula, a researcher can precisely plan their layout before printing, ensuring the final poster is visually appealing and easy to read from a distance. Let us apply this to a real-world design scenario. A researcher is designing a poster with a total printable area of 10,000 square centimeters. The design standard requires exactly 40% of the space to be graphics. How much physical area is that? First, we translate the 40% requirement into a usable decimal format, which is 0.40. Next, we multiply this decimal by the 10,000 square centimeters of total available space. The final answer is 4,000 square centimeters. This tells the researcher exactly how much physical space on the board must be reserved for visual data to maintain a perfect design balance. We have covered a lot of ground today, so let us review the key takeaways. First, remember that a seminar presentation is the vital bridge between your isolated research and the global academic community. Live presentations are essential because they provide invaluable peer feedback and networking opportunities that written papers cannot. Second, strictly managing your time allocation is what separates a professional researcher from an amateur. Finally, by using simple mathematical models, you can perfectly optimize your slide counts and poster layouts. Mastering these skills will ensure your audience understands your core message and will drive your future scientific inquiry forward. Great job today.